Hello students, this is the first of a three-part final exam review video. I'm going to be going over some of the material, well, really all the material, from elementary statistics, the final exam review that was put together by the college. Hopefully you got a chance to take a look at that packet. If you didn't, it's on the website. Take a look at the packet, see if you can answer the questions, and then I will try to walk you through the answers. All right, here we go. For the first question, it asks us to identify variables, individuals, populations. These are all vocabulary terms that you need to know. Remember, the variable is the actual thing that's being measured. The individual or subject is the either the object or the person or whatever it is that the variable is describing. The population is all such individuals in the world. And remember, the sample is all such individuals that we are looking for. The shape of the distribution, you should remember skewed right, skewed left, uniform, symmetrical, bimodal. Those are all different types of shapes of distributions. Continuous versus discrete. Remember, continuous means you can subdivide it. It can take any value, whereas discrete means it can only take specific values. And here's the histogram. This was the histogram that was provided in the answer key. You should be able to make a histogram just by hand. For question number 2 is pretty similar. A difference was the class width. Class width is determined by looking at the actual class and figuring out how many values fall between there. So 5 to 9 is 5, 6, 7, 8, and 9. That's 5 different things. So the class width is 5. Discrete versus continuous. This is discrete because we can't subdivide it. We're only selling cups of cappuccino here. We're not trying to sell 1.25 cups of cappuccino. That's ridiculous. It asks us to take the frequency chart and do some analyses to it. For example, how many Starbucks locations sold at least 10. Remember, at least means 10 or larger. And then a percentage is taking that number that we just found and dividing it by the total. For number 3, it asks us a couple of different things. It does ask for discrete or continuous. This one's discrete, and I know that it might be a little confusing because there are decimals here, but I want you to think about it like this. It's discrete because the price can't go between cents. For example, $59.99, the next highest price is $60. We're not talking about $59.995, so it's not really continuous. It does get pretty small in terms of decimals, but we can't get between the cents. So we do call this discrete. It asks for the shape of the distribution. You could make a histogram by hand. I chose to use the calculator. This is a box and whisker diagram, or box diagram, I think they call it on the calculator. Anyway, you can see that it is skewed right because the left line isn't really very visible, and neither is the first quartile. You see the median in here, you see the quartile 3 and the maximum. It's much more spread out to the right. If you look at the numbers, it's pretty easy to see as well. All right, here are the answers. For number 4, we're asked to find the missing relative frequency. Relative frequency always sums up to 1.00. That represents 100%. If it's a probability distribution, it does the same thing. The students that had the score of at least 63, well, from 63 and up, we got 0.24, 0.20, and 0.32. That's 0.76 in total. Then we multiply that number, that 76%, you can think about it like percent, times 25. And the 25 is coming from here. It's the total number of students. So 76% of 25 is 19. Then it tells us 800 is the total number of students. So we're using this relative frequency, which is 0.56, to estimate the total number of students who scored 52 to 84. So if 56% of students were supposed to score between 52 and 84, we take that number, we multiply it by 800, which is the total number of students, the population, and we estimate that it's going to be 448. Here we're asked to find the sample mean for a frequency table. You might be asked to do this on the final exam. Multiply each number by its frequency and add those numbers together and divide by the total number of numbers, 4 plus 5 plus 7, etc. That's 27. So the sample mean for frequency is 20.6. Then it asks us to make a relative frequency histogram. A relative frequency histogram is only different from a frequency histogram, which is this, because on a frequency histogram, the Y values are actual frequency numbers, whereas on a relative frequency histogram, the Y-axis is these decimals, not frequency, but relative frequency. And in order to turn frequency into relative frequency, we take each of these numbers and divide by the total. So 4 divided by 27, 5 divided by 27, 7 divided by 27, etc. The shape of the distribution is skewed right. This is not to say that every single distribution that you'll ever see is going to be skewed right. It just happens to be that most of these distributions are. The sample mean, we show that calculation here. And then we're asked what the average age of a student is. It's about 20.6. Remember, this is a statistic. It's okay for the statistic to not make sense in the context of the problem because we're asked for a statistic. We're not asked, if you identify one student, what would you guess their age to be? It's asking for an average, which is a statistical measure. The data comes from a representative sample. In this case, we randomly selected, it says we randomly selected 27 students taking a statistics course. So random eliminates the bias, and the appropriate population, we're making a guess about statistics students taking a statistics course. And these folks are all taking a statistics course. So it is an appropriate sample. For number 6, we're given all these numbers, and you know what you can do with these numbers. You can put them into the calculator, stat, edit, put them into L1, and then do stat calc 1var stats. The 1var stats gives us all this. It gives us the x bar, which is the sample mean. It gives us s sub x, which is the standard deviation. It gives us n, which is the sample size. It gives us the min, quartile 1, the median, the quartile 3, and the maximum. This is otherwise known as the 5-number summary. It will not remind you that a 5-number summary is min, quartile 1, quartile 2, quartile 3, and max. You're going to have to remember that. The box plot was easily made. This number here is 31. This number here is 41. This number here is 52. It's all coming from the 5-number summary. Remember the first thing you do when you're drawing a box and whisker diagram, draw the number line and make sure these values are evenly spaced out. Because if you just draw a box and whisker without drawing a number line, it's going to be wrong. For the frequency distribution, it's asking for the measure of the center, which one is larger. If there are larger extreme values to one side or the other side, the mean gets pulled that way. So in this case, there are larger extreme values here, which means the mean is going to be pulled upwards. The mean is not a so-called resistant measure. Resistant means, it doesn't get affected by extreme values. And the median is much more resistant. All right. The next page continues with that problem. So if you haven't already done so, pause the video, try to answer them, see if you get it right. Okay. The first question here asks which one is a better description of the center of the data set. The median is always better when the frequency distribution is skewed. Whether it's skewed right, whether it's skewed left, the median is going to be better. If it's symmetrical or if it's uniform or, if it's symmetrical or uniform, the mean would be a better description of the center. The test score does not exceed 76% for 75 students in this class, 75% I should say. You're analyzing it in this way. You're looking at 75% of the students in the class, the lower 75%, the test score doesn't exceed 76. Because if I were to say, well, what about this value? Well, for this value, 100% of the students in the class, the test score doesn't exceed, whatever it was, 96 or 97%. The test score, this should not say does, is at least 41 for 75% of the students in the class. Well, for the top 75% of the students this time, the test score is at least 41. I wouldn't choose this, the minimum, because that means the test score is at least 31 for 100% of this class. It's a little hard to think about the first time you're looking at it, which is why you're seeing it now on the review sheet, so you'll be able to answer the question effectively on the final. For correlation and regression, remember it is dealing with x and y variables. The x is the cause, the y is the effect, the x is the explanatory, the y is the response. And it asks us to state the units for these variables. Percent change in wages, percent is your unit. Percent change in consumer prices, percent is your unit. And it tells us the smaller the percentage change in wages, this we could call the cause. And then the percentage change in consumer prices, this we could call the effect. Which of the following is a possible value for a correlation coefficient? Remember, that's R. R is between -1 and 1. I gave a helpful Googled image here for what happens with the correlation coefficient. If it's 0, that means the relationship is extremely weak. If it's -1 or +1, let me slide this over a little bit so you can see the negative. There you go. If it's -1 or +1, that means it's strong. -1 means it's strong negative, which means it's going downwards. +1 is strong positive, which means it's going upwards. In this case, the only legitimate answer is 0.7 because we're looking for a number between -1 and 1. D is out. And we need it to be positive because as this one gets smaller, this one gets smaller, which means as this one gets bigger, this one also gets bigger. That's a positive association. For the next one, we're talking more about scatter plots, and you can see that this one has a stronger relationship because the points, the observed points, are closest to the predicted line. This one is a little bit weaker, and this one's weaker still. In order to make an estimation or a prediction using a scatter plot, the easiest way to do it is putting the number into the equation. But if you don't have an equation, you estimate by looking at the graph. The estimations should be pretty straightforward. 20 grams of fat corresponds to 400. We're looking for the line. Remember, if it's asking for a prediction, we're looking for the line. So we go to the line and we go over. 40 grams of carbohydrates, we go to the line and we go over. The observation points are closer to the line for fat, which means it's a more accurate prediction. If the points were farther away from the line, that means the line is bad or not as good, which means that it's not as accurate a prediction. Which nutrient has the weakest impact on calories? Well, that would be the weakest relationship. They use this word on purpose. Sugar is the weakest because the observations are farthest away from the predicted line. All of these have the same direction. They're all positive. Even though they differ in terms of their strength, their direction is the same. They're all going upwards. All right, number 9, this is a weird pagination. I know that the actual question is on the next page. Pause the video, try to answer those questions, and then come back and see if you got it right. All right, taking a look at letter A, it asks us to identify an individual in the subject. Remember, all of these dots represents one of those 19 developed countries, and each of the 19 developed countries, let's refer back to it real quick here. Each of the developed countries have wine consumption in liters of alcohol per person and death rate from heart disease per 100,000 people in those countries. So it's trying to relate whether wine affects the death rate from heart disease. And it appears as if there's some sort of correlation, not necessarily causation, because remember, if we see a correlation, it doesn't necessarily mean causation, but we know they happen at the same time. As the wine consumed increases, the heart disease-related deaths decrease. That's a negative association, and this is linear because, well, it's a straight line. For this case, we do get the LSR, the least squares regression line, otherwise known as the linear regression line. So we're able to use this to make a lot of predictions. If we increase the alcohol by 1 liter, which means X goes up by 1, we're asked to figure out what happens to the predicted death rate from heart disease. Well, if the X goes up by 1, this overall value is going to decrease by 22.97. So we're decreasing by 23 deaths per 100,000 people. Now keep in mind, we're writing 23 here, not 22.97, because we're predicting how many actual deaths are going to happen. For F, it says find the death rate from heart disease, and it's asking us to figure it out based on 5 liters of alcohol. Well, remember, liters of alcohol is our X value, so we substitute in X 5, and then we get our answer 145.71. For number 10, it's asking about baseball, asking about winning percentage versus on-base percentage. The first question asks us to figure out what happens with an increase of 5%. Remember that 5% is 0.05, so we're substituting that into the equation just like what we did with the wine consumption and heart disease-related deaths, and we get 0.147. Would it be a good idea to use the model to predict winning percentage for 0.156? This is called extrapolation. Extrapolation is outside of the range of the model. Our model only goes from 0.310 to 0.362. So asking us to predict something that's out here is crazy. It's just not something that's within our experience. And then based on the model, it's telling us on-base percentage is 0.350. Remember that on-base percentage is X. So we substitute in X and we get out a number. All right, that was the first 10 questions of the final exam review. I'm going to post another video for part 2 and another one for part 3, so stay tuned for those. All right, students, good luck studying.